welcome again. So today is a day where most of you guys been waiting for, and got a lot of requests to make a video about this topic, where we will talk about the Modbus multi-drop or multi-hop network. Okay, if you remember in the first part, let me change the pointer to a pen. Okay, if you remember the first part, we talked about this module, about the RS module, how to hook it up to the Arduino, how to use it to connect between two points, or master and device 1. Today we will use the same module, but with a network, more than one device. Okay, and this is how we're going to connect them. Okay, this is the simple network. Exactly, we have 3 devices today, device 1, 2, and 3. Okay, so let's get started. I'm working with. So this module I already explained about it in details in the first parts. Okay, this is the module, this is the physical module that I will work with. Okay, and this is the schematics of the module. This module is converting the TTL signals from any MCU or Arduino to a pair of signals, okay, that can be communicated to another device by using RS protocol, or what we call it is a differential signals, A and B. Okay, these are the RS485 specifications. I already explained again in details. If you want to learn more, please you may refer to the first part of this tutorial. I will leave the link in the description down below. Okay, so how we connect the modules. So here again, I also explained previously, but here I will just repeat it very fast. So first of all, we need to, here just an example of 2 nodes, node 1 for master and node 2. For sure we will have more than one, but we'll see how we will do it later. Okay, so first of all, REDE need to be short on both of the devices. Then REDE will go to pin number 12. Okay, both of them go to pin number 12. Now let me change the pen ink, let's say black. Now DI will go to pin number 11. DI go to pin number 11. Let me change again. Where's the ink? Pointer ink. Let's go for this. Now the RO will go to pin number 10. RO pin number 10. RO pin number 10. Okay. And for sure VCC go to 5 volts. And also for this module, also VCC need to go to 5 volt. And take that again. Ground go to ground. Now we come to the differential output, or the A and B signals. So the A will go all the way to A. And B will go all the way to B. Okay, so this is only 2 modules. Okay, so now if we want to connect more than this, so we just need to duplicate the modules. Okay, so let's take a screenshot of this and open the pins, copy. Let me open the pins. There we go, and paste. So it will be exactly same. Copy, paste. So now we have node 1, 2. This one will be node 3. Right there. So this one will be node 3, and this one will be node 4. That's too much. Okay, that's enough. Okay, so here, as I said, exactly the same, but we need to link A again to the A. Again, A go to the A, and also B go to B. Okay, that's all. Exactly same connection, exactly same circuits. When we need to expand it, we just need to multi-drop or multi-hop. From this node, we take A and B to this node, take from this node to the next node, and next node all the way to the end. Okay, so this is our connections. Okay, guys. So next, this is the exact link or the exact circuits what we discussed just now. So now let's go to see the physical connection, how we implement this on breadboard, and also we start with the software implementation.
Okay guys, so as you can see here, I already put all the components on the breadboard. So this is our base station, and here it is the RS module, and here we can see node 1, 2 and 3, and these are the modules that corresponding to the nodes. Okay, and each RS module is already linked to the pins from the Arduino. Okay, so, and also you can see here the A and B from all the modules being shared. You can see here these 2 wires from this module, or they can to this module, and from here to this, from here to this one. Okay, and here are all the control signal for the modules could be connected by using pin number 10, 11 and 12. Okay, so now I'll use this Arduino Uno as a base station or as a master, that it will request and send instructions to the 3 nodes. Okay, so these 3 nodes could be far away from each other's and only connected with 2 wires. Okay, so this is the breadboard. So now we can move to the laptop to start implementing the software. And one thing to be mentioned here before we go to the software, there is no other sensors or circuitries being connected to each node, whereby the data will be fabricated for every node just for the sake of demonstration. So I will assume there is a temperature and humidity sensor in each one of them. So the node itself will return or reply to the base station about its temperature and humidity. But these 2 data will be fabricated inside each node, hard-coded. Okay, so no need to add more complexity and more sensors to the circuits. Okay, let's move on.
Okay, guys, just to recap. So as we can see here, we have node 1, 2, 3, 4. We have 4 nodes. So node 1, let me change the color. Node 1 will be acting as a base station. Okay. And then the rest will be node 1, node 2, and node 3. Okay. So the first one will be acting as a base station, and the second node will be act as node 1, and the next will be node 2 and node 3. So yeah, the base station will act as a master, where it will request data from the nodes, node 1, node 2, or node 3. So we will design the software to address these nodes. So when the base station will send the request, it will dedicate the request to each individual node, so they will know the response, or they will know what to respond to in case the node got the request that nodes belong to itself. So we're just going to cancel it or ignore it. Okay, so all this we will learn in this tutorial. I'm not sure if it will be in one video, or I will chop it into more, depends on the time, if it will be lengthy. So yeah, this is the scenario that's gonna work with. So each node, it will has a fabricated data of, let's say, temperature, humidity. Yeah, temperature and humidity. Each node will has these parameters: humidity and temperature, and also here temperature and humidity. Okay, so these data will be provided by the node. For sure, we don't have any sensors. We're just like we fabricate. We add some fake data or fake information to the node just for the sake of testing. Okay, so the base station, for example, it will request the temperature from the node number 2, or request the humidity from node number 3, and etc. Okay, so yeah, this is what we're going to do in the software. So let's get started. Okay, so at this stage we will develop the base station code. So here I already opened new base station empty Arduino code for the base station. Okay, there we go. So let's add some comments here. Let's call this is a base station code. Okay, so for sure we need to include the serial or sub-serial. Again, we use the angular bracket because the library is at the main Arduino library folder. So here we need to include the software serial.h. Then we need to define 3 variables. Define rs, ro. This one will be at pin number 10. Let's copy this for implementation. So define rs, here we have di. pin number 11, D11, and then we have RS, DE, RE. This one at pin number 12. Okay, so far okay. Then we need to define or declare the object of the source area. Let's copy paste, this copy. I believe this one, guys, should be familiar with this code because this one is exactly same like the one we developed first time in the first part. RS underscore base station of RO and DI. This one should be I, capital, where this one should be RXTX. Okay. So now we counter the setup function. Setup function, we need to declare our serial because we're going to use it a lot. Serial.begin with baud rate 9600, and also our soft serial base station with the same baud rate 9600. Okay, now we have this mode, or this pin, we need to declare it as a output pin. So I have pin mode, this one as output. Okay, this one we use it to activate the transmitter or the receiver buffer. And since this one is the base station, so it will initiate the transmission, so I need to set this pin to high. So we have digital write. This one high. So far should be okay. So just need to display some message on the serial to acknowledge that the base station is ready. So serial dot print line base station is ready. Okay, let's compile it. Should be okay until this far. We didn't do anything new yet. Now we come to the loop. First we will check if the serial is available. If the serial is available, then we need to do something. If it's available, we need to set this pin to high. This means we start to transmit because we got the data from the serial, so it's going to be sent from the serial sent to the RS. So set this to high. Then we send it. Use this one. Dot write. We will write what? We will write whatever serial is ready. Okay, let's close this one and delete this part. Okay. Then here is better to give some time delay. Let's say 10 millis. After that, we set the pin to low. Why low? Because we will start to listen to the channels. Okay. And here we'll check if we got something from the RS. If the RS is available, then we need to print out on the serial. Serial right. We write whatever RS is got. Okay, that should be it. Let's compile and upload to our base station. Again, if you remember, my base station was Arduino Uno, I guess on COM7. Arduino Uno, correct? Yes, Arduino Uno COM7. Let's hit upload. Should be okay. Okay, it's uploading, then beautiful. So if we open now, you can see here we go, the base station is ready. So now we can move on and develop the other nodes code. Okay guys, so now is the code of the nodes. So let's say this is node 1 code. Let me copy from the master or from the base station. Actually, it's almost same. So let me copy all. Come to the node. I copy all. I paste it in the node sketch. And then I will change this to node 1 code. This one's be the same. These all will be the same. These and be the same. This one also okay, so it will be activate the receiver. This one should be low to activate the receiver. Okay, now we will say node 1 is ready. And inside the loop, let's say also okay, if we start with the serial. If serial is available, then this one should, this is wrong. This one should be high, should be same like this, and this one should be high. Okay, let's compile this and send it to the base station again. Okay, Arduino Uno, COM7, and same. Okay, compiling now should be okay, no problem. Updating, here we go, done update. So yeah, this is the correct way. Just now we done some small mistake. Let's copy this and go back again to our nodes. So from the nodes we change the loop overall. Okay, so in the loop if the serial is available, okay, first serial available means we send it from serial to the RS, so this one need to be high, correct? Then we send or write whatever we read from the serial, give it some delay, make sure our date has been sent, then we set it to low. So this block is correct. Now we come if the RS is available, or okay, if this one is available. Let's change this one actually also. RS sensor node. So all the one will be RS sensor node. Sensor node. Okay, if RS sensor node is available, so we need to define block. This one keep it for now. We need to define string as equal to this one. If RS sensor node dot read string enter the new line. Okay, enter the new line, we read all the string, put it into S. Then let's add some delay, make sure everything is being read correctly. Then I will print it on the serial. This one will be print line. I will print line word will print S. This one should be the correct one. Compile. Oh yeah, we changed this to sensor node. Now compiler should be happy. Okay, good. So since this one's for node number 1, I already connected to, or no, let's connect to number 3, let's connect it to number 1. Okay, so now I connect the node number 1 to my laptop, and let's see, it's Arduino, yes, Uno, COM4, yes, this is the nodes, and let's upload. Uploading, and should be done in a second. There we go. So now we should see node number 1 is ready. How about the master? Where's our base station? Base station. Okay, base station is ready. So let's test it out. This is the base station, and this is the node number 1. So if I send base station, let's say hello nodes. Oops, I didn't get it. Only H. Why? Baud rates should be okay. Let's test it out more. Nothing. Node nothing. Let's see why we got this issue. Could be a loosey connection, I believe. Nope. Code should be okay. Base station is ready, but this one receives only HY. let's go to the base station. Yes, I've done too many issues here. Base station also. This one shouldn't be in mode. Should be digital, right? No wonder. Base station should be digital, right? I'm sure you're gonna scream on me. What the hell is this? I'm sure the same thing goes to the nodes. So node should be not in mode, but digital right, okay. Now should be fine. Okay, we found a big fat mistake here. Let's see the base station. Digital right, correct. This is compile and uploading. Should be finished very fast. Done. Okay. Let's check now. So from the base station, let's say hello. There we go. Now we can get it. Then they say, okay, got it. So now let's go back to node 2. Again, node 2, let's go to the nodes, and this one should be node 2. And upload. Yeah, this is the main issue was just now. Actually, I'm not sure what I was thinking, but it should be digital right, not pin mode. Pin mode actually is another thing, just to say the pin mode was output or input, not the high and low, whatever. So we've done mistakes happened. So now, I'm not sure it's done. Let's upload again. This is node number 2. Let's upload again. Okay. Reading, done, happy, done, thanks. So now let's go to node number 1. Node number 1 is ready. Upload. Okay, guys, so here I've learned something new. Don't be too confident from your code from the first time. You might expect some mistakes. That's for sure. Okay, guys, so the thing here I want to highlight here. Okay, let's see now. Node 1 is ready and the base station is ready. The thing I want to highlight here is whatever the base station send, let's say hello nodes. See, all the nodes will be listening to it, will be receiving the same exact message. You see now, node number 1, it will receive this. If I now go change to another node, now I change to node number 2. There we go, as you can see here. If I send the same message, see, it's going to receive it as well. If I go to node number 3, if I send the same message, it's going to receive it as well. So it means whatever the base station sending a message, all the 3 nodes can receive exactly the same one. Or it's just broadcasting. But that doesn't work like this. Why? Because we need some addressing scheme here, addressing to address the request to which node that we are talking to. For example, from here we say, hey, node 1, send me temperature equal what? Like this. So this node 1, temperature equal what? It will send to all 3 nodes. Then it will find or search of the nodes identity. If the identity or the sequence or the number of the nodes match the current node, then to say, okay, this message for me, then I'm going to forward the data to the base station. Okay, so now we are now at the node number 3. So it means this message is going to be ignored or discarded because the destination not match the current one. The base station sent to node number 1 destination. So the source will be base station, the destination will be node number 1. But the current one is node number 3, so this one should be discarded at the node number 2 and node number 3. But node number 1 should process the message and reply the base station with the current temperature value. Okay, so yeah, so from here we already fixed the issue just now, sorry for that. So let's move on, and we will have another example of how to broadcast the data to the sensor nodes that they are on the line, and after that we will see how to develop our own addressing.
Okay guys, so at this step we will change the node code, okay, to control the built-in LED on the Arduino board. Okay, so first of all, to do so, we need to add on or define the built-in LED. We copy this, same. So pin mode, either pin 13 or we can use LED underscore built-in, okay, as output. So the changes will be, yes, will be here. So if we got any data from the RS, by the way, the changes in this step will be only for the nodes code. The base station code will be maintained the same. Okay, so if we got any data from the RS, we start in the string, then we print the string. So here we will decode or check if the string that we got is equal to 1, then the built-in or digital write, copy this, hopefully this time I won't make any silly mistakes, digital write, the built-in LED should be high. Otherwise, if not 1, so the built-in LED will be low. Yeah, should be, that's it. Again, the base station code should maintain the same. So let me upload it now to the nodes. So node 3, I'm connected to node 3. Let's send it out. Okay, it's compiling. Should be finished within a second. What issue? Oh, it's open COM7, but by the way, oh, thanks God. Actually, the node shouldn't be on COM7, should be on COM4. Actually, COM7 is the base station. The Arduino Uno is the base station. So COM4 will be the node. Now should be okay. Compile again. Now should be happy. It's uploading.
Okay, good. So node 3 done. Now I connect it to node 2. Okay. And connect to node number 1. Code 1. So this should be 1. This one actually is just a command, no need, but it's okay. Okay, so while uploading, I will go to open the master. There we go. Or the base station. Okay, so this is the base station, and I will open the node. This is node 1. This is the base station. So now I will test it out. For sure, you guys, you cannot see it now, or later I'll show you on the bench. So if I send 1, here we go. I can see all the LEDs are high now. By the way, you need to, I see here we receive 1. You need to change this to change the parameter of the string or the UIR string to no line ending. Okay, no line ending, and it's send 1, this one for the master or the base station only. If you send 1, here we go, I can see they are on. If you send 0, here we go, they are off. Again, 1, on. So that's a proof that if we send any data now from the base station without addressing, so all of the connected nodes will be response to the changes. Okay, later I'll show you on the bench. That's proof without any addressing scheme, any request sent from the base station to the nodes will be addressed by all the nodes. Okay, because I'm not talking to a specific node and say, okay, node 1 on, node 2 off, etc. Okay, so that's why if you see on bench later, if I send 0, all of them will be off. If I send 1, all of them will be on. Okay, let's go to the bench and see what's happened on the breadboards.
Guys, so as you can see here, this is our base station, node 1, 2, and 3. They're already connected and linked, and all the boards being powered up. So now I will send 1 to the base station and keep focusing on these LEDs. There's a LED here, LED here, and LED here. Okay, I'll send 1. Here we go. You see, when I send 1, all the LEDs, these LEDs are high or activated. Okay, now I'll send 0. There we go. I send 0 now, all of them off. That's mean whatever request has been sent by the base station, all of them will be response. Why? Because there's no addressing scheme. Again, 1 on, 0 off, 1 again. Okay, so in the next steps we will learn how to develop our own addressing scheme whereby the base station will be talk to each individual node privately, okay, to ask it to turn on an LED or response with any data like temperature, humidity, or any other data that's been related to the system. Okay, but for the time being, all the data being sent by the base station will be broadcast to all the nodes linked to the system, and all of them will be response because there is no addressing scheme. Okay, so let's move on.